What's up, math scholars? We are doing 9-5 day 2. My fourth period is my best class, and that's why I like to record in there. So rather than taking the compliment with a smile, they're grumbling right now, but how do you guys feel about being the best? Woo! Fourth is the best! Fourth is the best! They're actually booing. This is so rude. Alright, go ahead and write down what a supplement is. You learned this back in middle school. But a supplementary angle would be, well, two supplementary angles would be two angles that add up to 180 degrees. Go ahead and write down our big idea of the day. Our big idea of the day is that the sine of an angle would equal the sine of that angle's supplement. And that's going to be a big key when we're solving these triangles. Sometimes two angles actually have the same exact sine, and that way we could have two triangles existing that have the same characteristics as far as angle measurements and sine measurements and all that. Congruent supplement theorem. I'm going to use my unit circle real quick here, and we're going to try to figure out what the sine of 60 is. What is the sine of 60? The y value at 60 degrees. There you go. That's 3/2. Now, can you guys tell me what the supplement of 60 degrees is? 200. 120. 200. No. Supplements must add to 180. The supplement. I gotcha. So what is the sine of 120? Also, radical 3/2. Okay, so that's the key. When we're doing sine inverse today, there'll be two possible solutions. All right, that's where we're headed with this. So let's try 150. What's the sine of 150? Here's my unit circle. Yep. Sine of 150. 1/2. And I'll just tell you the other question. What's the sine of 30? 1/2. So you kind of notice everybody across the way has the same sine value because they're supplements. Good. Ready to rock to a triangle thing? This is a lot of information. I'm not going to expect you to write it all down, but what I would want you to write down is that a side triangle, a triangle where they provide two sides and an angle, could potentially have two solutions, one solution, or no solutions. Okay? So a side angle case could have two solutions, one solution, or no solutions. And I'll sketch out what a side angle case is. If I know this is 12, I know this is 15, and I know this is 27, there could possibly be two triangles that would have those dimensions. One would be acute, and one would be obtuse. Possibly, maybe. We shall see when we solve. All right, so notice they are going ahead and they're giving us some information. Since they said it's 115, I will go ahead and sketch out an obtuse triangle. Sometimes I just drop a random triangle, but they're normally acute when I draw them. Angle A, I'll make that 115 because it's a little larger. They do provide small a, which doesn't have to be across the way, so that's a reminder about that. If they give me little b as 11, that would make this top left corner my big B. And while I'm labeling, let's just go ahead and call this right-hand corner big C, and this small little guy over here small c. All right, class, you know my question, right? Do we have a complete set of partners? Yay! So we can use law of sines. You cannot use law of sines if you don't have a complete set of partners. So I'm going to start myself off with that complete set of partners. Sine of 115 goes with 20. Let's just go ahead and solve b next, since we know that small b is 11. So if you're really astute at looking at this closely, you do see a difference from yesterday. We are missing an angle today. Yesterday we were always missing sides. We're still going to use cross multiplication. So you're still going to start off by doing 11 multiplied by sine 115. Let's go ahead and do that together. 11 multiplied by sine 115. And then you'll divide that 9.96 divide by 20. Click enter. At this point, you should be seeing a number between 0 and 1. I'm seeing 0.498. That's what sine b equals. We still have an additional step to perform. Anybody can guess what our additional step is? Very good. Kylie's a scholar. So we have to inverse sine it to cancel that sign and solve for b. So inverse sine. So the keystrokes on the calculator will be second sine, second answer button. That'll plop that 0.498 into there for you. Second sine, second answer button. 29.89. So since that's degrees, I'll just round it to 30 degrees. And that is angle B. Now we have to do something we've never done before that's kind of stems from the supplements rule. We have to explore the possibility of the supplement of B also being a solution. Because the supplement, basically B has a sign value of 0.498. The supplement of 30 would also have a sign value of 0.498. What is the supplement of 30? So we're exploring the possibility that this angle B might be 150. Is that a valid possibility? No, because we cannot have over 200 degrees in a triangle. So in that case, my supplement possibility is just trash can. So this is only one possible solution to this triangle, having the 30 there. So let's finish solving the triangle. If that upper corner is 30, and this was a 115, how big is C? 35, thank you. I like when scholars have worked ahead. And then I need a little more workspace because we need to do the law of sines one last time. So sine of 115 goes with 20. Sine of 35 goes with C. You'll solve that out just like yesterday. You won't have to use any sine inverses or anything. 20 times sine 35. Enter. Divide by sine 115. You guys get 12.66. 12.66 right here. My triangle is solved. Sweet. That was fun. All right, we're going to do another triangle. Let me go ahead and sketch it. This is a 51 degree angle. So I'll just go with this type of triangle. A is 51. Small a is 30.5. Small b is 5. If I put my small b down at the bottom, I have to put my large b up at the top. And that would make this large c and small c. There's my labeled picture. Hey class, do we have a complete set of partners? Yay, we can use law of sines, my favorite. So 51 is partners with 3.5, and sine big B is partners with 5. So how's our setup looking? We good? We agree? Sweet. Let's do some cross multiplication action. We're going to take 5 times sine 51. Then divide it by 3.5. Now keep in mind, this should be a number between 0 and 1.
No solution.
Oh my gosh, you might be right. Let's try a sine inverse right now. You didn't know that because of this, right, Ethan? It's okay. I should have whited that out, but I didn't. When you do a sine inverse of 1.11, it does say domain error. So that makes that answer undefined. And what that means, I know you guys are in geometry, what that means is it would be impossible to construct a triangle with these dimensions. If you want this to be 51 degrees, this to be 5, and this to be 3.5, your sides just won't touch one another. Okay? Make sense? Alright, I'll hit pause, let you. Okay, let's go ahead and sketch this triangle out. So A is 40, small a is 13, small b is 16. It is definitely one of those angle side scenarios that we've been working with all day. Let's bring my big B and my C. You got everything labeled correct? I'm going to shrink this down because I'm going to need some workspace. Forgot to make it small. There you go. Well, you can probably already look ahead and see where we're headed with this. Basically, there's going to be two types of triangles that could be constructed with these dimensions, one being acute, one being obtuse. So we will be kind of exploring that and how that works mathematically. Do we have a complete set of partners, class? We sure do, yay. That makes me happy. It's a 40. So sine 40 goes with 13. Sine B goes with 16. We are ready to cross multiply our 16 times sine 40. Enter. Divide by 13. At this point, you should get a number between 0 and 1, because this is a number you will be sine inversing. Everything's looking good. Let's sine inverse both sides, and that'll be our angle B. (52°). Now, we have to do what you do every single time you do a sine inverse, and that is explore the possibility of the supplement of B. What's the supplement of B? 180 minus 52. So the question is, would 128 be able to fit in this picture? Like, would I have enough degrees left for angle C? Because you have to have 180 degrees in every triangle. Yes. So rather than me making that a 120, let's me just draw a new picture with an obtuse angle in it so you can visually see it a little bit better. So I'm going to do my best job at drawing an obtuse angle B that is 128, and I'll have this one be my one with the 52. Okay. So basically there's two possible ways to construct a triangle with a 40 and a 16 and a 13. One would have a 52-degree angle B, and one would have a 128-degree angle B. So we have two cases. And we'll kind of split the workload. If you're sitting on this half of the room, you guys are going to finish out triangle 1 for me. And if you're sitting on this half of the room, you guys are going to finish out triangle 2 for me. And I'll save you some time. Okay? I think my sketch is done. I'm going to see if I matched everybody in the room. So people sitting on this half, did you get 88 for big angle C? Did you get 20.21 for little c? Sweet. People in that half of the room, did you get 12 for angle C?
Yes.
And then 37.84. Uh-oh. Oh no, I messed up. I went with 40 going with 13 and 12 going with C. Let me just type it again. 13 times sine 12 divided by sine 40. 4.2?
Yes.
Aha! I just typed something in wrong. It happens. Thank you for checking. Yep, you did get it right. Mrs. Hart typed something wrong. You know, I should have recognized I typed something wrong. The smallest angle should live across from the smallest side. That's called the Hinge Theorem. So if it hinges wider, the side will be longer over there. And if it hinges smaller, the side will be smaller over there. So I should have recognized I missed that. We have one more topic. We ready to go to the last topic? Area of a triangle. So traditionally, the area of a triangle formula is 1/2 base times height, right? But in reality, you don't always have the height of a triangle. So this is an area formula that you can use if you know two sides and you know the angle that's sandwiched in between them. You can either write down all three versions of the formula or just write down one version of the formula and understand how it works. So this is basically how it would work. If I would know this side and I would know this side, and I would know this angle sandwiched between, I would do 1/2 times 10 times 12 times sine 22. That's how it works. Make sense? So don't necessarily get confused with B's and C's and A's. Just understand side, angle sandwiched in between. So this would be a side angle side concept, in other words.
Wait, so you just do 1/2 times 12?
12 times 10 times cosine 22. Or, sorry, sine 22. So they have this version rewritten to fit every possible scenario. I don't bother writing it down 3 times, I just understand how it works. All right, we decided just to use this example problem I sketched as our first example. So my area of this one, if you want me to label it so it can match this formula exactly, I would label this A, and then this B, so this could be small b, and this C, so this could be small c. It'd be 1/2 times 12 times 10 times sine 22. 1/2 12 times 10 times sine 22. This is an area. So when you do areas, you go with units squared. I think we have enough time to do one more. You want to do it as a graduation problem, or you still think you need to do one with me?
Graduation.
Okay, sounds like they're ready. Keep it here for 1 sec. Yep. Great. All right, let's see who can graduate. Try this one at home if you're watching the video. Video. All right, raise your hand if you graduated. Yay, looks like we got some smart people. So your homework you already have. If you are watching this on the video at home, it should be at the end of the slideshow. Yep, here it is. It's called Day 2, Law of Sines. All right, so thanks for watching along. Bye-bye.